All right, objectives. I can find patterns with decimals. I can use order of operations with decimals. I can solve equations with decimals. And then finally, I can solve word problems with decimals. We've done some word problems with decimals, but today we're going to be seeing a little bit more. Okay, so we've seen this slide before. Well, I should say my last class did, last semester. So patterns, sequences. I like to scan from left to right. If the values go up, you have one of two operations to choose from, either addition or multiplication. If the values go down, it has to be either a use of subtraction or division. Okay, so again, if you scan from left to right and you see the numbers are going up, addition or multiplication. If they go down, subtraction or division. Now this is without considering the sign, meaning positive or negative. So if you see the sign changing back and forth, then that'll be a whole different situation. I'm not sure that we're going to see that today. But yeah, sometimes the decimal is just simply changing location as well, which we will see, but you'll see a few different situations on the assignment. Something like this one. Okay, so I start just with these first two, 11, 5.9. Just from this, I can see that the values are going down. Okay, so again, why is it important that to know that the values are going down? Because I have to be doing either subtraction or division on this, all right? Okay, well, if it's division or if it's subtraction, it has to be going using the same subtraction or division every time. So you can't be like, well, we're going to divide by 3, and then suddenly you're dividing by 18. I guess you could, but that's not really for this class, okay? So on this one, I like to start with subtraction, okay? So I would look at this from 11 to 5.9, and I would say, how far down did it go from 11 to 5.9? And that would be down. So again, in your calculator, you just type in 11 minus 5.9. Again, I'm not doing this by hand. I would just type this into the calculator, let it do the work, and I would see it went down by 5.1, 5 1/10. Okay, that means that if the pattern continues right here, it's subtracted 5.1. From 5.9 to 0.8, it should also subtract 5.1. So we go here and we say 5.9, and then we're going to subtract. So 5.9, again, I already know that it should go down 5.1, and if it does, then we should have found some kind of pattern here. So minus 5.1, and it gives me the 0.8, which is, in fact, the next value in the pattern. Now, again, since we know it's going down by, so we're saying we're going to subtract 5.1 there, which was here, minus 5.1. Now we can take the next value, which was 0.8, and we should be able to subtract 5.1. So here we showed that you subtract 5.1 there. Now we're going to say this pattern should continue. So if I subtract 5.1 from 0.8, I should get negative 4.3. Boom, negative 4.3, and what do you know? That is the next value. Now, seeing it happen twice is good enough to say that I know the pattern. But again, I'm just showing you that this is going to continue. And I'll do it one more time. So from negative 4.3 to negative 9.4 should be subtracting 5.1. So again, we take negative 4.3, we subtract 5.1, and we should get negative 9.4, which we do. And put that in the calculator, and then you can see that that will actually occur. So it says, find the next term of the pattern. We just found what the pattern is. You're always subtracting 5.1, or I guess you could say adding negative 5.1, but I like subtract. So this means we're going to take that negative 9.4 to find the next value, and we're going to subtract 5.1 there. And that will tell us the next value in this pattern, which is going to be negative 14.5. So I'll put that in there, negative 14.5. I'll circle it, because from negative 9.4 to that value, we subtracted 5.1, just like you can see is the pattern throughout. So if you wanted to use an equation on this one, you could. Again, you're just going to take the first two terms. You got the 11, and then you got the 5.9. Now, again, we have already determined that we use subtraction here, right? So that means you take 11, you'd say, I'm going to subtract something in order to get the 5.9 right here. Okay, now you'd say, okay, I'm gonna use principles of equality. Whatever I do to one side, I gotta do to the other side. So we would want this negative, really it's negative 1x to be by itself. So it's a subtract 11. This way it's going to zero out the 11 in black there, which it will do. So that does zero that out. We've already dropped the negative 1x, and then 5.9 minus 11 ends up being negative 5.1. And then the last thing we do is we want that coefficient of x to be positive 1. So again, whatever you do to one side, you got to do to the other side. So divide by negative 1, you get x is 5.1. Again, this tells us, this would have told us what we are subtracting every time. So minus 5.1, minus 5.1, minus 5.1. Again, that's the second method, which you don't have to like, but it is a pretty consistent method. So let's look at this pattern. Take a minute, look at this pattern, and tell us what the next value will be. Just write it down, and then we'll go over it. All right. What do we get here? Okay, that's it right there. All we're doing is taking the decimal and we're moving it, I'm going to say to the left. Okay, so for example, the decimal, it originally started here. It was you could say 3.0. Then it moved over to this one, and then it moves over, and then over, and then over. So of course, from there it's going to move, when I say over, I mean to the left. One more place value. Some students would say it's adding a 0 to the decimal, and that's okay. It's the same thing. So I'm saying I'm looking at it from the decimal perspective, but you can look at it from the 0 perspective as well, okay? So yes, that would be, looks like it's 3 tenths, hundredths, thousandths, 100,000, 300 thousandths. Personally, I like these just because you just got to see the decimals moving. That's it. We didn't have to worry about subtraction. We didn't have to, I mean, it's division, if you wanted to know. It's taking each of these and you're dividing by 10 to get the next term in the pattern. But again, I kind of prefer to look at it just from the decimal. All right, find the next term of this pattern. Okay. Yeah, try this one out. See what you get. So the first thing I notice on this one, and again, I'm going to do this two different ways, okay? But the first thing I notice is if I were to take away the decimal, you'd have a pattern of 4, 16, 64, 256, and then 1024, okay? Now again, I know there are decimal places. We'll deal with that here in a second. But for me, in this pattern that I have written, it shows the values going up, even though the decimals would show the values going down. Is that okay? Yeah, it is, because we can deal with the pattern of the decimal here in a moment. So we would say, what are we, again, we see the values are going up. So this first method that we're going to use, we're saying that it's going up in value. Okay, now does that mean we're going to use addition or subtraction? Well, if you're using addition, you say 4 plus 12 is 16, plus 12 is not 64. So I cannot use addition here. I would have to use multiplication. So if I'm using multiplication, what am I multiplying by? Well, if we know our multiplication tables, which hopefully we do, at least this one, 4 times 4 is going to be 16. Okay, and that means 16 times 4 would be 64. You can check your calculator on this. Times 4, you get 256. Times 4 is 1024. Now, you would just do these ones really to check, but you can put in the calculator 4 times 4 is 16, or that's one that we should know. And then 16 times 4 is 64, and then you can check these other ones. Now, of course, that means that would do 1024 times 4 as well. And again, without the decimal, that means 1024 times 4, enter, it's going to be 4096. Now, you notice I've written this further to the right so that I can put in decimals as I need. Now, that's the multiply by 4 thing, but what's going on with the decimal? Well, the decimal, here we had 1 decimal place, then 2 decimal places, 3, 4, and then 5 decimal places. So this one should have 6 decimal places. In other words, what's happening is that you're taking these, in order to move the decimal, you're dividing each of these by 10, okay? And that is how the decimal is moving to the left. So just like we did before, whether you're counting like I did before or you're dividing it by 10, you would have 6 decimal places. 1, 2, 3, 4, 5, 6. There's my decimal, and I like to have that pretty zero in the front too. And that should be our answer right there. Here's what I mean by showing this method, okay? So we know that we're multiplying each of the values. So if I were to go from 4/10 to 16/100, I know I'm going to multiply it by 4, but that would really be 4 over 10. Okay, and that means that you would repeat this pattern over and over and over. So between the next two, you're going to multiply by 4/10. Between the next two, and then the next two, and then finally the very last one, which is how you could find the answer. Again, that's one way to do it. Okay, so you kind of jumped there, and then you said instead of doing 4/10, I just kind of with some guess and test. You said I multiplied by 0.4, and I saw if you multiplied each of these by 0.4, then you were in good shape, which is good. Now the way that I showed is a super nerdy way to do it, in my opinion. Here's another nerdy way to do it. So I know this is it's probably not going to be super helpful, but it may be helpful. Okay, so this is going to take us back to equations, which we're going to see later on today, okay? So if you were to look at this pattern, the original pattern, without saying it's going up, so I can see I went from 4/10 down to 16/100, down to 64 thousandths, down to 256 10,000ths, and then down to 1,024 hundred thousandths. Down, 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 which means for our second method, so let's kind of split this up. For the second method, we would say, we know we're going to be going in a downward pattern here, okay? So we're saying we're going to go down. Now again, with subtraction work, it's possible, but this one, we should expect some form of a division. And this method, by the way, kind of works with all of them, as long as you understand which operation you're using, okay? Now, most of you use multiplication too, so this may be a little counterintuitive to what you were thinking originally as well. But it's going to kind of mix in with what we're going to see with equations, okay? Now, all we need is any two terms that are consecutive, okay? So I usually just say, let's take the first two terms. So the first term is 4/10, or 0.4, and then the second term is 16/100, like this. Now we know that we're using division, so I would have to take 0.4 and divide it by something in order to get 16/100. Now, in the past, we'd say, instead of just making this a blank, we've already seen this before, where we said, you know what, just make it a variable like this. In fact, what I'm going to do is, instead of showing the division like that, I'm going to show the division like a fraction. So we're going to divide this by x, and then we would have to solve this equation for x. Now, I don't remember if we've done something like this before, but we would use principles of equality to solve for x at this point, and would say, you know what, this principle of equality stuff, we know for sure we can't have an x on the bottom, so I would get rid of that by multiplying both sides by x. Why am I multiplying? Because it was division, and if you ever see division or multiplication, you use division or multiplication in order to create a 1. Where's the 1? It's right there. Okay, but if I do it to one side, I do it to the other side, now I'm left with 4/10, and this equals 16/100 times the x. And then finally, I'd say my last principle of equality, because what I would really like is 1x, not 16/10 of an x. I would take that and divide it by itself. But again, if you do that to one side, you need to do it to the other side. Okay, and 0.4, or 4/10, divided by 16/100 is going to give you 2.5. This means that if we were to go back to the original pattern, so I'm going to rewrite this stuff, or copy it down here. This means if you were to take the original pattern here, and you were to see, if you were to divide, you could take 0.4 and divide it by 2.5. You can check this in the calculator. It will give you 16/100. And then you can continue that pattern. You could say 16/100 divided by 2.5 is going to be 64 thousandths. And if you divide that by 2.5, you're going to get 256 10,000ths. And this will work for the next term in the pattern, which means it will work for the final term in the pattern as well. Okay, now this up here was multiplication. Multiply this by 0.4. Down here we're saying divide by 2.5. But you get the same answer either way. Why is this? Because they're inverse operations. And 4/10, which is divisible by its simplifiable, it would be 2/5, is inverted into 2.5, which would be like 5/2, 5/2. Saying inverse, but reciprocate is probably the more accurate word there. Okay, order of operations. So we've seen this before, parentheses, exponents. Now again, multiplication or division, it has to occur from left to right. The or is the main statement here. It's not always PEMDAS, no matter what you've been told, no matter how many songs have been sung about it. PEMDAS is not always the way that it is. The D and the M can switch, and same with the A and the S. Again, you're scanning from left to right, seeing which one comes first. So if division comes first, then you have to do that one. And then if you're doing addition or subtraction, you have to do the subtraction if it happens first on the left. So we've seen this on exams. We've seen this on, well, I guess all we do is exam, but assignments as well. And math teachers love this. They like to see, just to make sure that you're paying attention here, they'll do something like this. They'll say 25 divided by 5 times 2, okay? And if you do this first, and you say, oh, 5 times 2 is 10, boom. I don't have to correct anymore, and it's very easy to be like minus all the points because you're way out of order on this, right? Because you have to do the division first. You'd have to do the division first. Or, like we've seen before, they'll do subtraction as well. They'll do 11 minus 2 plus, I don't know, 8. And if you do this, if you do 2 plus 8 is 10, boom, we know right away, no points for you because you've done this out of order. Now again, it's like an operation, which I think we've talked about before. If you're going to do things out of order and you were actually operating on a patient and you were a doctor, you just mess things up pretty bad. Yeah, well, you might kill the patient, right? Now, I know math problems are not patients and they're not people breathing and stuff, but it's kind of the same idea, and if you can imagine that, then, and it helps you, then do it, okay? So again, on both these problems, you'd have to do this division first because it happens first on the left. Here you'd have to do the subtraction first because it happens first on the left. Okay, so perform the indicated operations. Now again, what we don't want is for you to just type this in to your calculator, because you can. You could type this into the calculator exactly like you see it, and then it would give you the answer right away. But on exams, you need to show some work. So that's what we're going to do, okay? Now again, we have to do this by the order of operations. The first operation in the order of operations is parentheses. Are there any parentheses? Yes, there is, right here. So, again, this is how, if your work looked exactly like this on an exam, you get full credit. Even though I'm not stacking in first, I'm going to have to subtract, but I'm not stacking and subtracting on this. All I'm doing is going to my calculator, 6.83. If my calculator works, 6.8, it's working. Oh, okay, it's not. 6.83 minus 3.43. And again, I just type this into the calculator. I push enter. Okay, 3.4 or 3 4/10. Now, when I do this, I kind of like to show the rest of the work, but since, again, we're not really necessarily doing this, well, I'm still going to do it. What the heck? So now, again, the nice thing about the order of operations, which we've talked about before, is that it allows you to focus on one part of the problem at a time and not multiple parts at a time, even though the calculator could do it all by itself. Okay, we did the parentheses. There's no more operations inside the parentheses. That means we get to go to the next operation, which would be exponents, and I do have that exponent of 2. So in my calculator, I'm going to put this in, right? It's 3.4 to the power of 2, enter. Now, if you can't find your power of 2 button, then you're just gonna do 3.4 times 3.4, and this is what I get. Okay, now we took care of that exponent. We get 3.4 to the power of 2, and we got 11.56 or 11 5600ths, if you like it that way. And now we are on, because there's no more exponents, let's do multiplication or division from left to right. Now again, on this one, as it turns out, if you did 10 times 11.56 first, you'd actually be okay because they're separated by the addition sign. But just to make sure that we remember that we should do this from left to right, I'm gonna do the 5.28 divided by 2.2. Enter. And my calculator says, oh, that's 2.2 right there. Thank you, calculator. Okay, now again, I'm dropping this. Not everyone shows this particular step. A lot of students would just do this one together like this, but again, I'm just kind of going step by step. So this one, 10 times 11.56, that should be 115.6. Okay, so now we have 2.2 plus 115.6. And the last thing I got to do is add these together, which again, you could use the calculator, but that should be 117 and 8/10. Bam, we did it. Now again, did I stack and subtract? Did I do long division? Did I stack and multiply? I did not. All I did is I typed this stuff into my calculator as I was going down. And so these little V's, some students like, that little V is going to work as work? Yeah, that's fine. That's all I need to see. In fact, you know, again, I may have shown more work than you'd even necessarily need to put on an exam. Yeah, so it's not 2.2 because I don't know why. Yeah, it's 2.4. So let's let's fix that. It's not going to change my answer very much, but again, it's going to be wrong. So I'm going to change my answer. 2.4. It's going to make it 118 total. What I got? 118. Now, I'm going to say 118. If you say 118.0, it's the same thing. But please do not make the same mistake that I just barely did. My calculator gave me the right answer. I just wrote down the wrong thing, by the way. And that happens. I promised that I would make mistakes. Oh, there's one. All right, try this one. See how you do, and then we'll go over it. But order of operations. So, as usual, parentheses first. And yes, there is a set of parentheses here, which, once again, I'm just going to put this in the calculator in order to get the difference between these two values. And when I do, I got 12 and 3/10. Okay, so that's 12 and 3/10. We didn't do anything else with the rest of that problem. That was all we were focused on. And so we can just drop the rest. Now, there is multiplication between the 7 and 55/100ths and the 12 and 3/10. There's multiplication there. But I'm not worried about that right now because we just did the parentheses. Now, the next operation we should look at is exponents. So I don't see any exponents. And that's okay. Sometimes you just get to skip an operation. Sometimes it's parentheses. In this case, we get to skip exponents because there is none. Okay, so that means we're on multiplication and division from left to right. So I see the first on the left is division. So that means I'm going to have to do 15.4 divided by 7.7. When I put this in the calculator, I got 2. Now, the rest of this, right, we still have the 8 plus the 2, and we still have plus this 7.5 times 2.3. I will say this is one thing that happens when students do this kind of stuff, especially when it's in the middle of the problem, they forget that maybe like the 7.7 has been used up, so they'll do like 2, and then they'll still have like divide by 7.7. Okay, once you show the V, the value that you get from this V thing as our work, it eliminates those two because both have been used in an operation. So make sure you're not recopying things down that shouldn't be, or that you're miscopying things like I did on that last problem. Okay, so that was division, but there's still multiplication, right? Now it's not showing the multiplication, but there is some right there between 7 and 55/100ths and 12 and 3/10. When I put this into the calculator, I got 92.865. Okay, now again, everything else stays the same. We still got an addition right there. So it's 8 plus 2 plus 92.865. And if you were to add, so I'm just doing this from left to right, but there's only the same addition operation. So 8 plus 2 is 10. Now, if you wanted to just put this into the calculator and say, well, the final answer is 102.865, that would be fine. Again, I'm showing more work than you'd probably need to even show on an exam. But now that we've done that addition, add these two again with the calculator, 102 and 865 thousandths. That's going to do it right there. All right, now we already saw some problems where I set up an equation myself and then we solved it, right? Now, solving multi-step equations. Down here with addition, subtraction, multiplication, and division right here, these are what we call principles of equality. Principles of equality say whatever you do to one side, you got to do to the other side. Now that's if you put it there. Okay, so if I put in subtraction on one side of the equation, then I've got to do subtraction on the other side of the equation. Now before that, before we get to principles of equality, you should be looking for distribution. If there's any form of distribution, then there should be parentheses somewhere in the problem. Okay, now if there are no parentheses in the problem, then you don't have to worry about distribution. But if there is, then you will likely have to worry about distribution, okay?
Then what's distribution?
Now again, if there's no parentheses, there's no need for distribution. After distribution, if it's possible, because again, sometimes we get to skip distribution, you should always look for any like terms to combine. And this is on each side of the equal sign. You cannot combine like terms across the equal sign until you get to principles of equality. So, combining like terms means any term with an x, you combine. Any term that does not have an x, you combine. Again, it's on the same side of the equal sign there, though. Now, the third step, it says we're going to isolate the variable, and that means that we're going to get the variable, I'm going to say x, even though it's not always an x. We're going to get the variable on its own side of the equal sign. It doesn't matter which side it's on either. Now, in doing this, getting the x's on its own side of the equal sign, it will force all the numbers, anything that's not an x term, on the other side of the equal sign. Again, and that kind of goes back to combining like terms. Okay, now how do you isolate the variable? That means that anything that's with an x has to be zeroed out. And that's where those principles of equality come in. Specifically, that would be addition or subtraction. So we use addition or subtraction principles of equality in order to make zeros. And like I've said before, why would we want to make zeros in a math problem? Because zeros in a math problem are like people that we consider zeros. We ignore the crap out of them like they weren't even there or existed in the first place. And I know that sounds mean, but you know you do it too. So we're going to make those zeros. Why zeros? Because that's what we call a phantom zero. That it's there, it exists. We just don't want to look at it or think about it or ever. It doesn't affect the math there, okay? So that's why we want to make those values zeros. But again, we do that if we're going to make zero those out. Whatever you do to one side, you got to do to the other side, okay? Now this means that, see how we're using the two operations of addition or subtraction in order to make those zeros? That means that if we see the operations of addition or subtraction with the x's, that we should expect addition or subtraction as well in order to make those zeros, okay? So that's part 3 there. And then the fourth step is to force the coefficient to be a 1. Okay, now multiplication and division is the principles of equality that we're going to be using in order to make ones. Okay, and again, it's specifically the coefficient. Usually, we're just going to use division in order to do this, especially with equations, but it's possible that we may be forced to use multiplication from time to time. So, force the coefficient to be 1. Really, again, since we're mainly using division on this, what we're going to do is divide both sides by the coefficient. Okay? Now, the reason that is because the coefficient is whatever it is, but anything divided by itself is 1. So, for example, let's say that you had something like 3x equals 12. Now, we know 3 times 4 is 12. But again, as a principle of equality here, in order to make that, instead of the coefficient of 3, we want the coefficient to finally be a 1. So we take the 3 and simply divide it by itself. Now again, I put that divided by 3 in purple there, which means that if I do it to one side, I must also do it to the other side. 12 divided by 3 would tell me that that x value is 4. Now this goes back as well to stuff that we learned in the first semester, because the x value that you get at the end needs to guarantee that the equal sign is true, okay? Because in the end, what you don't want is something that says 6 equals 15, because that's weird, all right? The x value that you get needs to ensure truthfulness of the equal sign, because if it's not true, then what the crap is this for? You could just throw in any number that you want. And this goes back to what we talked about as well in the first semester. There's only one value that will make these true, but there's an infinite number of values that will make them false, which means if you're guessing, you have an infinite possibility of getting this false. wrong, I guess, whatever you want to say, right? So let's say we're working with a 15. The only value that's going to make that true is 15. This type of equation is what we expect in the end. It's the last thing we should see before we make that coefficient a 1. We make it a 1, not anything else. We are forcing this to happen because that's what we want. We don't let the numbers control us. We control the numbers. So here's our first example, solving an equation, and typing's hard for Sal, so that's should be 14.8392, which is, it's kind of a big decimal number, but I'm not doing any of this by hand, so the calculator is going to be doing it for me. Thank you, calculator. All right, now the first thing we would do is look for distribution, but I don't see any distribution, right? If there was distribution, then we would expect to see parentheses, but I don't see any parentheses, so I'm not going to use distribution. Fair enough. Okay, is there any need to combine like terms? No, because on the left side of the equal sign I have an x term, 3.59x. Really it's negative because the minus sign makes that negative. And then we have the 6.27. This is a constant or a non-x term. This is an x term. Cannot combine those, okay? So that means that there's no distribution, there's no combining like terms, and I can go straight into principles of equality. Now, like you've seen before, I like to draw this line through the equal sign, so if I do any work here or here, that I have to do it on both sides. Okay, whatever I do to one side, I must do to the other side. That is a principle of equality that will maintain balance in the equation. I know you wanted me to say the force, but that's a different type of nerd, okay? So I'm not saying I'm not one, I'm just not going to go there. Okay, so we say we want to isolate the variable. In this case, it's an x term. Isolate means that negative 3.59x, what I'd like to do is just take this and drop it, negative 3.59x, and see what that equals. Meaning I don't want this 6.27 with it. I don't want to drop it with it. What I'd like is some kind of zero term there so I can ignore it, like I would a person. So that 6.27, since I see it's separated with subtraction, I expect either subtraction or addition. In this case, I'm going to subtract 6.27. But again, why am I doing that? Because I want it to be zeroed out. Zero, anything minus itself is going to be 0. So 14.8392, I also need to subtract 6.27. And again, I don't care that I'm lining up the place values now because I'm just going to type this into the calculator and then see what it gives me. And it says it's 8.5692. All right, that's pretty good. But that just isolated the x's, negative 3.59 of our x's. The last thing we need is to see a 1x, not negative 3.59s of them. So how are we going to make this 1x? You just take that negative 3.59 and simply divide it by itself. Divide by 3.59. But again, if you do it to one side, you need to do it to the other side. And again, there's no expectation of long division here. That's a 9. Okay, so negative 3.59 divided by itself is going to be a positive 1, and that's important too, that you understand that that 1 is positive. If it were negative, then we've done something wrong. Okay, but that's a 1x, which is what we want. But then I go to my calculator and I type in 8.5692 divided by 3.59. Holy crap. Here's what my calculator shows me. I'll just write this down. Okay, now that's pretty ugly. That means this decimal, it's actually going to go further than that. I'm not saying it's irrational, but it's ugly. So usually if this happens, what they'll do on the assignment, they'll say round to the nearest, I don't know what they're going to say. They may say tenths, hundredths, maybe even thousandths. But they don't usually go past thousands. This one I'm going to do hundredths. Okay, so the hundredths is an 8. To the right is a 6. That's 5 or more, so I need to add 1 to that. And then I end up with negative 2.39. Yeah, so I have this written as 1x. I like to keep the 1 while we're still learning that it needs to be a 1. But yeah, a lot of students are like, I don't even like seeing that 1. You don't have to show it. You do not have to show it, yep. So you say x is negative 2.39. And that was a lot of work right there, and it feels good. because we did a lot of work. The truth is, though, if you were taking an exam, you'd probably want to know for sure that the answer is correct. I'm nerdy enough that I would want to. So here's what you're going to do, because you can check. On some of the exams, they will. They're going to say, please show us. Yeah. So if you wanted to, because on the exams, they're going to say, something like prove that your solution is correct or check your work or something like that. Okay, so you're going to go back to the original equation. Okay, so that's 6.27 minus 3.59x equals 14.8392. Now just understand, in this class, they will say you need to check. In future classes, they will not say that you need to check, but you still should check because this is a good way to guarantee that the answer is going to be correct. Okay, right now, I'm pretty sure that x is about this. Now, am I going to get exactly this answer in the end? No, because I rounded. If you want to use this value, you can do that. But what I'm going to do is I'm going to take that x. Let's see if I can do that. I'm going to take this x, and I'm going to replace it with that negative 2.39. Okay, so that's my x value. We still have everything else. Let's see if I can. And this should equal 14.8392. So because of the unsurety, because, you know, I make mistakes on this, I'm going to put a question mark over my equal sign, and then all of this at once I'm going to type into my calculator. So I'm going to go to my calculator. I say 6.27 minus 3.59 times negative 2.39. Enter. And I get 14.8501. Now, is that exactly 14.8392? It is not. And that's okay. And here's why it's okay. And I kind of explained this already. But 14.8501 is it came from the rounded answer of negative 2.39. But our answer wasn't negative 2.39. It was negative 2.3869633788, which is why it gives us not exactly the value that we were kind of looking for there. Okay, so even though that's false, it's okay because it's close enough to each other, right? It's only off by like 1/100th or less, more, whatever. So again, I just can't emphasize this enough. I got a false statement when I checked, but it's true because it was rounded up here. All right, so this one, we do have parentheses on this one. So you should expect distribution, but try it out. See if you can do it. Okay, so with the parentheses, we're definitely expecting some distribution. So that means right here, with 5/100ths, you'd multiply that. If you like to see that as 1x, feel free to do it. But it's 5/100ths, it's got to multiply by both of the terms. So it would start as 5/100ths times 1x's. Okay, so that's going to be 5/100th x's, like this. And then, again, this is something you do in the calculator, but it's 5/100ths times 60, which when I put it in my calculator, I got 3. Now that's positive 3, so it shows as plus. And the 60 was positive because of the plus sign as well. So on this next part, okay, so again, you can look at that as 1x. I would recommend it until you get used to this. So some students like to look at this and they say it's 0.02 times 1x's, or groups of 1x's. But it's not. Because of the minus sign, it makes that a negative 0.02, which means that's going to be minus 0.02 x's. And that comes from 0.02 times 1. Now, once again, it's not just 0.02, it's negative 0.02. And it's going to be multiplied. Again, I would say it's not just 40, but it's negative 40 because of the minus sign. So when you put this into the calculator, you're going to get positive, so I should put a plus sign, 0.8. And then, of course, this still equals 4.1. Okay, but that's all of the distribution that we have. So be careful because it's the sign thing, specifically the minus sign here and then this minus sign that throws students off. Now that we have this, so that's distribution, but after distribution we look for combining like terms. So I I'm starting with my x terms just because it's the first one on the left. So how many x's is that going to be? Well, you had 0.05 x's, and then you'd say minus 0.02 x's, which is going to be 0.03 x's, positive. Okay, now again, you just put that in the calculator and see, they get 3/100ths of an x right there. Okay, now that's all the x terms, but I have constants as well. I've got 3, and then I'm going to add 0.8, which is going to be positive 3.8. Which again, you can just put that in the calculator if you need to, which I recommend. Okay, now this still equals 4.1. Why are we not doing anything with the 4.1? Because it's on the other side of that equal sign. So we're now looking at an equation that's very similar to the last problem that we did at this point, which means that, you know, if we started here like this, then you'd say, okay, I know I just jumped right into principles of equality because it wouldn't show distribution and it wouldn't show combining like terms, but they are there. Okay, so we had to get to this point ourselves this time, whereas last time we didn't actually have to do that. So now that we're here, we know that there is no distribution, there is no combining like terms. So again, I look at my x term, which is 3/100ths of an x here, and what I need is to be able to just drop that so that it's by itself, 0.03 x's, and this can equal whatever it equals, right? Okay, so that means the plus 3.8, we don't want it there. We can't have it there, so I'm going to zero it out by subtracting itself, minus 3.8. But again, I put that minus 3.8 there in orange. So if I do it to one side, I must also do it to the other side. And that is going to give me 0.3. And again, that's just something you can put into the calculator. The last thing I need out of this is an old-fashioned 1x, not 0.03 x's. So again, how do you get 0.03 to be 1? Just divide it by itself. So divide by 0.03. If you do it to one side, you must do it to the other side as well. So I want to say this is going to be 10, but I'm going to put it in the calculator just in case. Divided by 0.03, 10, boom. Okay. All right, so that means x is 10, and again, if you don't like to see the 1 there, you don't have to show it. But once again, you should check. Okay, so let's go back to the original equation. Okay, so this is the original equation as it was. But now we're pretty sure we know what the x is, so we're going to take those x's and we're just going to replace them with the value that we found, and that's just a regular old-fashioned 10. Now, since we're just checking at this point, I don't really need to make sure or show the work as I go. All I'm going to do is I'm going to check to make sure that equal sign is correct, but I'm going to type in the equation exactly like I see it. So I got 0.05, and then if you just look right above the 8 button, on most of the calculators, it's just right above 8 to the parentheses. Then you can type in 10 plus 60 in parentheses. You close the parentheses with the button above 9. It's just close parentheses. Minus 0.02. Again, you got another set of parentheses, open parentheses. And then again, it's not x, but it's 10 minus 40, close parentheses. Now, when I push equals on this, okay, because I just typed all of this stuff in to my calculator, I'm expecting it to show 4.1 because it should equal 4.1, and that's going to be true. So let's do that. Push equals 4.1. It does show that. This is a true statement, which means we have, in fact, found the solution. So on this one, again, there's parentheses. We're going to do this one together, but I do have parentheses, which means I'm expecting distribution. Now, I'm going to show you a mistake that students make on this one, which we don't want you to make. Now, this first part is not the mistake. So they'll do this part, right? 0.2 times 0.5 x's, and that should be 0.01. No, 0.1. There we go. 0.1 x's there. And then again, I would show this as 0.2 times negative 0.5, which is going to be negative 0.1 right there. Now, with that's all the distribution you need. The mistake that we see from students is where they say, you know what, I'm just gonna distribute because they love it so much. Like I'm gonna distribute there as well to the 1.24. Do not do that. That's not the distribution you want. That's a mistake. That again, it's a mistake that some students make. Not a lot of students, but some students make. And the reason why we do not distribute to the 1.24 is because distribution is multiplication. this is now addition between this multiplication and this value, so you can't multiply those two. Which means that what we have distributed is all the distribution, so we can bring the rest of this down. All right, so that's all the distribution. Is there any combining like terms? Sure, there's these two constants. There's no x terms to combine. So again, in the calculator, you just do negative 0.1, and then you get plus 1.24, and you should get positive 1.14 now. Okay, so now you got 0.1x plus 1.14, which I have in purple, and this should equal still the negative 7.86. Okay, so distribution, combining like terms, and now we're at the same place as we were on that first problem, because there's no distribution or combining like terms anymore, which means that we need to start isolating that 0.1x. So I'm going to take that, I'm going to drop it, I'm going to drop it by itself, 0.1x. It should equal something, okay? But I do not want that purple 1.14 there. Since I don't want it there, that means I'm going to have to zero it out. And again, if you're not sure why we're zeroing it out, it's because it's addition. Okay, remember, if you see addition or subtraction, you should expect to get zeros, and that will zero out. Okay, so that's my zero right there. On the other side, negative 7.86 minus 1.14, I believe that's negative 10, negative 9, negative 9. And then the last thing we want is a coefficient of x that's just a 1x. Okay, so right now it's a tenth of an x, but we want a 1x, so we're just going to divide both sides by 0.1. Again, both sides, that's going to make that a 1. Negative 9 divided by 0.1 should be negative 90. Okay, so that should be our solution, but again, we can check, so let's write that original problem down again. Okay, so there's my original problem. I'm going to take the x, and I'm going to replace it with negative 90. And this is something, again, I'm just going to type this in exactly like I see it, to the equal sign, and then I should get something that should equal 7.86. So once again, I go to my calculator and I just type this in. So 0.2 parentheses, open parentheses, 0.5 times negative 90 minus 0.5, close parentheses, plus 1.24. And again, when I push enter, I haven't yet, but when I push enter, I should expect 7.86. Oh crap, I got negative 7.86. Okay, so this is why you gotta be careful with your copying. Yes, it is correct, it's supposed to be a negative. So let's make those corrections right here, but I did get negative 7.86. Again, I just typed it all into the calculator. I thought it was wrong, and I was going to have to go back and check where I made some mistakes, but it's just, I copied it. I suck at copying, so. It is a true statement, which means we have, in fact, found the solution. Once again, if you want to show that as just an x instead of 1x, that's fine, too. Now it's saying the volume of rectangular solid, it's just a box, can be found using this formula. V equals LWH. That's length times width times height. You measure a room to be 2.9, come back here, 2.9 meters wide. Then it's 3.1 meters long, and then 4.25 meters tall here, okay? Now it's saying, what's the volume of the room? Well, the volume up here, it says the volume is the same as taking the length, and then we're going to multiply this by the width, and I am color coding this on purpose, and then times the, well, I color coded that poorly, but length is in purple for us. Height, there we go, okay? So this is plug and chug, which means the calculator is going to do all this work for us. I don't need to do stack multiplication here or keep track of how many decimals there are. I can just go to the calculator and then put this in. Okay, so my length in purple there, it says it's 3.1 meters long, times the width, which it says is 2.9 meters wide. And by the way, if you're worried that they're going to do 1 in meters and then like 1 in feet. That's not for this unit. And then the height, it says, is 4.25. So again, this is just something, I'm going to go straight to the calculator and type this in, and then whatever it tells me it is, that is my answer. And this is plenty of work, by the way. So in the calculator, I go in, I say 3.1 times 2.9 times 4.25, enter. Oh, okay, it's kind of an ugly decimal there, but it's not too bad. 38.2.2075. Now that's a pretty ugly decimal. It didn't say it around specifically, so I'm not going to. But now we need some kind of label. Well, everything was in meters, so I am going to put meters. Volume, however, is three-dimensional. Three-dimensional because you had meters times meters times meters. That would be meters times meters times meters, which is the same as meters cubed, or if you like, cubic meters, same thing. Okay, so circles, just a little bit about circles here because they're going to use these different terms on this. Center, diameter, radius, and then we're going to find circumference. We're also going to find area, but we'll wait a few slides for that, okay? So the center of a circle is right in the middle of the circle, and I guess maybe that's redundant. You can get pretty mathematical about this. But the center is the same distance to the edge of the circle in all directions, actually. And that's the center. Now the red line is the diameter, which is why diameter is written in red. So we can say, hey, look, we found a diameter. So the diameter stretches from one end of the circle to the other, but it has to go through the center. If it doesn't, then you'd have something, let's see if I can do this, something like this. That was kind of sucky. Let's take that back. The red one is diameter, but what they can do is so like a line like this is not a diameter because it doesn't go through the center of the circle, right? It goes from one end of the circle to the other, one edge to the other edge, but not through the center. So we don't want to worry about those. That's what we call a chord. You know, if you want to get real nerdy about that stuff. But I'm going to try to avoid that stuff. Okay. So we have the center, we have the diameter, the radius is related to the center. It's going to go from the center to any outside edge of the circle. So I'm showing this one right here. Let's see if I can do this with some technology. I don't know if that's great, but it's okay. That purple line represents one of the radius. And if you really want someone to beat you up and steal your lunch money, then you say radii, because that's nerdy as you can get, right? So just be aware, multiple radius is not radiuses technically, although I say it because I don't care. But nerds, they say radii. Yeah. So a radius is another way to say it. It's half the diameter. Some people like the radius, so they say the diameter is twice the radius. It doesn't matter. Again, the fact is that you just need to know what a radius and diameter is, because when they say find the circumference, they're going to give you either one of these on the assignment, okay? And if they say diameter, you need to know how to use that to find the circumference, but if they give you the radius, you need to know how to use that to find the diameter so that then you can find the circumference on this one right here. So the circumference is actually the distance. If you were to walk on that circle, and this isn't going to be great because my drawing sucks, but I'm doing the best I can. If you were to go around this circle from starting at one point and ending at that same point, that is what we would consider the circumference. I think I can spell that okay, circumference. There we go. Okay, so it's just circumference. Another way to say it is it's the perimeter of the circle, which is why we have that right there in the slide there. So it's just the distance around the circle. To pi. Okay, pi is the Greek letter P, which looks like this. Now, pi is it's an exact ratio of if you take any circle and you were to actually find the circumference, which is kind of nerdy, and you were to divide it by its corresponding diameter, then you would get a ratio of pi. So pi is also 3.14. Now, okay, be careful because depending on which math nerd you talk to, some may say it's like 3.15 or some kind of garbage like that. I don't care enough to say that it's something else or how to find it. Other math nerds, especially on my math channel, they get on and they're like, hey, look at this. It's not 3.14. I'm like, I don't really care. I was just trying to, I don't care that much about it. So if you want to get nerdy about it, this gets super nerdy, and then you could find other values other than 3.14. By the way, this decimal goes on forever and ever and ever. It never repeats or terminates. You guys remember what we call those types of numbers? So pi is an irrational number. It has more decimal places than this, but this is all I'm going to show. So this is the main thing that you need to know. In these formulas, which we're going to see for circumference and area, instead of pi, you're going to use something like 3.14. If they want you to use a specific value, then they will tell you which one to use. But for us, we're going to be using 3.14. So have that ready in your calculators. There we go. There's our circumference formula. Circumference is 2 times the radius times pi. I don't know how nerdy I want to get about this. Okay. Well, with that kind of green light, here we go. Double, here we go. Double the radius is the same as the diameter. So if you wanted to just find the diameter, if I can spell it. If you wanted to find the diameter and just multiply that by pi, you could. But again, the diameter is just double the radius. Again, however you want to look at it, just depends on you. I don't know, I guess maybe we can show both ways, depending on which value they give us. This, when it says find the circumference, we're going to use the circumference formula, which is the perimeter around a circle. Why don't they say perimeter? Because circles are so unique to math nerds that they have to use different vocabulary for it. So, welcome to math class. Okay, but again, for this, I'm going to be using a calculator for all these. Okay, circumference equals 2 times radius times pi. This one, they gave us the radius, so here we go. The radius, it says, is 4 feet. So in this formula, I replace the radius with 4. Everything else stays the same. 2 times 4 times pi, which again, it says round to the nearest tenth. And in terms of pi, okay, so I'm going to put pi in here. All right. Now, if you're looking for the pi button, there is a pi button on the calculator. Okay, so I type this into the calculator, and this is the answer that it gives me. It says your circumference, after putting those values in, is 8 pi. Thank you, calculator. That first answer is what we would say is in terms of pi. Okay, so this is in terms of pi. This first one, 8 pi. But it also says that you also need to round to the nearest tenth. Okay, so we need this also rounded to the nearest tenth for the circumference. Okay, so what you're going to do is you're going to go right above the enter button, push the double arrow button, and then it will give you the decimal. Okay, so this is the ugly decimal that I got. It did say it rounded the nearest tenth, which is the 1. To the right is the 3, which means the 1 stays the same. And just to clean this up, I'll just get rid of all this garbage here, okay? So you got... Now, just so we understand, the answer is not 8 pi, and it's not 25.1. I'm not doing this to be a jerk. I just want to make sure that everyone remembers to label their answers. These are in feet, okay? So make sure you put 8 pi feet and 25.1 feet. If you do not label these on an exam, you'll lose points, which we don't want. Okay, here's this one. Now we have a diameter of 12 centimeters. Find the circumference, round to the nearest tenth, and in terms of pi as well. Okay, this says the diameter is 12 centimeters. Now, if we remember, the radius is half of the diameter. So in order to find the radius, which for this particular formula we do want, and by the way, there's more than just because we need the radius for this formula. I'm doing it for more than just that, okay? So the diameter, we're going to take that 12 divided by 2, and that would be the radius, which is 6. And I'll even be specific and say that's 6 centimeters. Okay, so in terms of pi, you do the radius, which is, well, it's 6. Okay, so now we got 2 times 6 times pi, which again, you're just going to plug this into the calculator, and that will tell you the circumference immediately in terms of pi. So this is now going to be 12 pi's. And again, just to be specific, we'll say this is in centimeters. 12 pi centimeters, okay? That's my circumference in terms of pi, but now we need this to the nearest tenth. So again, this is the circumference. All I do is push the double arrow button above the enter button. Okay, so that's my circumference as a decimal, but it's not rounded to the nearest tenth, which I will now do. The 6 is in the 10th place. The 9 is 5 or more, so we're going to add 1 to the 6. And that now is going to be 37.7. Once again, we'll label this in centimeters. So we have the 12 pi centimeters, and then the circumference is rounded to the nearest tenth, 37.7 centimeters. Now, just to go back, if we remembered from the other slide, 2 times the radius, this part right here, is the same as the diameter, which is why it's showing the diameter is 12 times pi. So now again, that takes some experience to memorize that. But if you remembered for circumference specifically that it's just diameter times pi, you could have skipped this garbage right here. But you should get the same answer either way. So this is the area of a circle formula. Now this is where we need the radius. So if they give us a diameter, we're going to have to cut the diameter in half, just divide it by 2, and that will give us the radius. But it's just pi times the radius. You need this power of 2, which is, on the calculators that I'm using, it's 1 button to the left of 7. It should say something like x squared. So this example here, it says the diameter of a circle is 12. It's the same circle that we've seen before, but now I cannot just substitute the diameter in for the radius squared because it's not radius times 2. It's radius to the power of 2, which is different. So, in order to find the radius, which I do want, and I'll still do the work here, just to help us remember, the radius, we're going to take that diameter, divide it by 2, and that's going to be my radius of 6. Well, I guess this one's in inches. Okay, so the formula, I just take the radius, I replace it with 6. And now, in my calculator, for my area, I've got pi times 6 to the power of 2. That's going to be the area of this specific circle. Now, it's going to give us 2 answers here, even though it didn't ask for it. I'm going to give us 2 answers. The first one will be in terms of pi. This is going to be the same as 36 pi's. Okay, now we'll come back to the label. But this would be what it would be in terms of pi. You just type that in, it'll give you 36 pi. If it says, hey, go and round that to the nearest tenth, which it may do on the assignment, then we plug this into the calculator, 36 pi. Again, you're going to push that double arrow button above the enter button and just see what it says. So let's see what this one says. Okay, so this is what I got, 113.0973355. But again, I'm just going to assume that we want to round this to the nearest tenth. So there's a 0. The next value to the right is 5 or more, so we'll add 1 to that 0, making this 113.1. Now again, the last thing we need is some kind of label. So up here it was done in inches for us. So area is never just in single units because it's radius times radius. So it's also inches times inches, which we will write as inches to the power of 2, inches squared, or square inches. So I'm gonna go with this one. Let's see, I'm gonna assume that this is the one that we want, but we do have this one in terms of pi here in case it does ask for it on the assignment. You have $14. It feels weird to not have the 0 there, but $14.30. And purchase an item for $8.84. How much money do you have left over? The question here really, because we have the 2 values, is what operation are we using? Yeah, we're going to use subtraction. So you have a certain amount, and this means you're going to start with what you have, of course. Okay, and it says it's $14.30. So we're going to say you're going to have 30 cents. Yeah, $14.30. And then I guess I should clarify. I think on the assignment it shows is like something like 14.3. You're going to see that? Yeah, that's $14.30. It's 3 tenths, 3 dimes. Okay, but then, and this is where we know the operation here. You're going to purchase. The purchase indicates that you're going to spend money. which means you're going to subtract money from what you have, okay? Okay, well, how much? Well, you're going to purchase an item, so this is the value of the item. We don't know what the item is, but we know that it's $8.84. Now, in the past, we would have just been like, we're going to stack these and subtract them, and as fun as that was, and as much as we miss it, I'm not going to do that. I'm going to go to the calculator. I'm going to type in 14.30 minus 8.84, enter, and it will tell me how much I have left over. So leftovers, again, this is just from the calculator, but it's $5.46. And if you make sure you label this because it is a word problem. We just found the answer there. So the key to these types of problems is just knowing what operation you're doing. If it's subtraction or division, then order does matter. If this happened to be some kind of, you're adding to your money that you have, then the order does not matter. Same with multiplication, but subtraction like this one or division, make sure you have them in the correct order. So if a lineman works 9.5 hours a day on a certain job, now that's a mixed number, which maybe you weren't expecting in the decimals module. But here we go, the mixed number. So that'd be 9.5. Now, I'll show you how to do this in the calculator as well, but as a mixed number. But the job is paying $28.30 per hour. What is the pay for the day? So, yeah, I know you guys want them to get overtime, but we're not going to do that because it's going to make it more complicated. Okay, so if on the calculator, okay, so we'll enter the 9.5, but again, what operation are we going to use? Definitely expecting multiplication on this one because you're getting paid per hour. This much every hour. You're going to do 9.5 of those, 9.5 groups of this. Groups of indicates multiplication. So we know we are expecting some form of multiplication here. So we're going to multiply these two. You got 9.5 hours, 9.5 groups of the $28.30. Okay. So again, how do you put 9.5 into the calculator? Because I don't want to do any more calculating than I need to. 9.5? Now, so some of you have that decimal down, and it is 9.5. But let's say it was something like 3/7, okay, and that's a little bit not as normal as a decimal for us. So here's what you're going to do. You're going to go to the calculator because we want a mixed number. Okay, so you're going to type in, at the very top left, you're going to type in second. Okay, that's this one right here. Then you're going to push the fraction button. It's the N over D. And then on the calculator, it'll show the cursor with like a fraction like this or something like that. That's the mixed number. Okay, then you just you're going to type in a 9, so you'll push 9, and then you're just going to push the over button. That's this one right here. And then you're going to push 1/2, so 1, and then you're going to go down and push 2. Now, on the calculator, it shows you 9 1/2 like this. Again, if you know it's 9.5, you could have typed that in. Again, just expect other fractions, mixed numbers, because it's going to look pretty ugly. Times 28.30, and the calculator, for me, just put it directly into a decimal. It gave me this value. It gave me 268.85. So there isn't even a need to round. Just don't forget to label that in dollars. That's how much you'd expect to get paid for a day, working $28.30 per hour for 9.5 hours. All right, you sold mugs at a crafts show. On the first day, you sold 7 mugs, but lost $4 on each mug. On the second day, you raised, I guess, your price and sold 6 mugs with a profit of $3.90 on each mug. What was your total profit or loss? Write a profit as a positive number and a loss as a negative, no problem. Okay, so we're going to start with day 1, or first day. I'm going to call it day 1. All right, you're going to sell 7 mugs, and you're going to lose $4 on each mug. Okay, so that's 7 groups of negative $4 on each mug.
That's just 7 times.
So 7 groups of means it's definitely going to be multiplication, which means on day 1 you lost $28. Now you didn't have to do that negative 28 first, because we can make a full calculation in the end. So, but that is for day one. Now we're gonna look at day two, which says you're gonna make a profit of $3.90. Again, it's on each mug, which is important for us, because this time you're gonna sell only 6 mugs. Okay, so 6 groups of gaining $3.90 on each mug. And let's see, 24 minus the 40 cents, so that'd be $23.60, which you gained. So we're gonna add those two together. Okay, so 40 cents instead. So you're gonna gain $23.40 on day two. All we gotta do is combine these now. Now again, you could stack and add these, or 28's bigger, so you know it's gonna be negative. But again, I'm just gonna put this into the calculator. So I'm gonna type in negative 28 plus 23.40, enter, and the calculator says it's negative 4.60. Now again, we'll label that in dollars to show that that is how much you lost over the 2 days at this crafts show. The negative indicates loss, which means, whatever you gotta do to raise the price on your mugs or whatever, but hopefully you don't start knowing that you're gonna lose $4 on each mug. By the way, that's a difference of $7.90, so you could have sold them for more in the first place, but whatever. You recently hired a mechanic to do some necessary work. The mechanic gave a quote of $220 for parts plus $53.75 an hour for labor. When the work was complete, the total bill was $542.50. Complete the following steps to determine how many hours of labor were needed to complete the work. A, write an equation you can use to answer this question. Let X represent the number of labor hours worked. Okay, so there's 2 things that you are going to pay for. All right, so let's look at how much you will pay first. First, you're going to pay for parts. And then second, you're going to pay for labor. Okay, now just with this, and this isn't going to be the full equation, but it's going to be part of it, how much you pay, and then we'll have some kind of total. But for the parts, it says up here, you're going to pay, see if I can do that better, $220 for parts. So for parts, you're going to start off paying $220. That's without labor. That's without anything else, just the parts. The labor, on the other hand, is going to be $53.75 every hour. Now, if you put in here $53.75 like this, the problem with this is it's only for 1 hour. It doesn't say how many hours the mechanic worked, which is why we come down here and we say you got to let X represent the number of labor hours worked. So that's how many labor hours they worked, X. This is how much they charged every hour. We're going to take those two and add them together to get how much you paid. But then we're going to say, you know what, we got some kind of total amount that was paid as well. And that's what this should equal. How much you pay should equal the total. The total, it says, was $542.50. That's the equation. So on the assignment, that's the first box that you're going to fill in. The stuff that we just put in there, okay? So I'm going to copy this down here because I'm going to now need it in order to solve for how many hours the mechanic worked. Okay, so down here, notice I'm setting up principles of equality because there are no parentheses and there's no combining like terms. So what I need to do is I need to be able to take this $53.75 and I need to just be able to drop it. So I can't have the 220 there, so subtract 220. But if you do it to one side, you need to be able to do it to the other side as well. Principle of equality. So that would be $322.50. Now, just so we can understand, because we can interpret this as it is, and remember, this was a plus sign, so this is positive. If it were negative, then I'd keep that. If this was minus, I'd keep this negative. This means that you pay $322.50 just for the labor. Yeah, it is a lot of money. It's theoretical, anyways, too. So. All right, so last thing we want here. So this is 53.75 X's. That's how many hours. What we want is one of those, okay? So one of those will tell us how much you will pay for, in fact, I'll make it green, That's how much you'll pay. That's how many hours they work. That's what I meant. Okay, so how do you get that 53.75 to be a 1? Just divide it by itself, 53.75. But if you do it to one side, you need to do it to the other side. So I go to my calculator. I type in 322.50. Oh, that's a decimal. Divided by 53.75. Now I remember it is 6. Now, the answer is not 6 because this is a word problem. You can't just put 6 if you want full credit. Very good. 6 hours. Boom. Okay, so that means that we had the 2 boxes, which we want. Let's see if I can do this right. Okay, so the first one, the first answer was here, this part, and then the second answer, 6 hours. Boom. All right, that's it. We did all 4 objectives. It's quite a bit, but we finally did it.